Before we start writing any code, let me show you what we are going to build in this video. This is not just another chatbot. This is real GitHub AI agent built entirely using Java, Spring Boot, and Spring AI. Now watch this. I am going to ask the AI, list all my GitHub repositories. Now pay close attention to what happens here. I haven't written a single piece of code or if-else statement to understand this sentence. The AI figures out what I want, select the correct Java methods, calls the GitHub API, and gives me the result. These are all my GitHub repositories that are available with my GitHub account. Okay, now let's try something even more interesting. Let's ask, create a repository called Spring GitHub Demo 1. Okay, as you can see, the GitHub repository has actually been created inside my GitHub account. Let's verify this. And there it is. The repository was created by our AI agent. But here is where things get really interesting. Now I'm going to ask, what repository did you just create? Okay. Notice something? I didn't mention the repository name again. The AI remembered our previous conversation because we have added conversation memory. We are going to build this complete AI agent from scratch using Java, Spring Boot, Spring AI, tool calling, conversation memory, and the GitHub REST API. So let's begin by creating a new Spring Boot project. I will go to Spring Initializer. We will use Maven, Java, Spring Boot 4.1. Let's name this as GitHub AI Agent. We will select the Java 21. Okay. Dependencies we need are Spring Web, Lombok, and we will select the OpenAI. Okay. Once the project is generated, we will unzip this and open it in a VS Code. Let me show you the pom.xml. I have added this Spring AI starter model chat memory manually, and I have also added Spring Boot starter web client. The memory dependencies allow the AI to remember previous messages within the same chat session. Next, we will configure application.yml. So here I have configured OpenAI API key. I have also specified the model that we want to use so that Spring AI will automatically create the chat model for us. And our AI needs permission to interact with GitHub. For that, you have to generate a fine-grained personal access token and configure it here. Now our application can securely communicate with GitHub. This chat memory section enables the chat memory configuration. Let's look at the folder structure that we have created. Config folder, controller, service, tools, model. Now let's create our GitHub config class. Imagine we have 10 different methods that communicate with GitHub. If we create a new HTTP client, inside every method, we will end up duplicating the same configuration again and again. Instead, Spring allows us to create one reusable REST client bean that the entire application can share. Let's understand what's happening here. First, we have specified the GitHub base URL. This means that every request made using this REST client will automatically use GitHub's API endpoint. Next, we have set the authorization header, and this GitHub token is from the application.yml file. After that, we have configured the accept header. This tells GitHub that our application expects responses in JSON format using GitHub official API version. Now let's see next class, that is chat client config class. Earlier we configured how our application talks to GitHub using the GitHub config class. Now we need to configure how it talks to the LLM. That's exactly what this class does. Instead of creating a new chat client every time we receive a request, we will create it once as a Spring Bean. We have also added conversation memory. This is where we connect our chat memory to the chat client. Think of the message chat memory advisor as a bridge between the AI model and conversation history. Every time the user sends a new prompt, this advisor automatically retrieves the previous messages from the configured chat memory. Next is the chat service class, which contains the core business logic of our AI agent. Whenever a user sends a prompt, this service is responsible for forwarding the prompt to the LLM, registering the available tool, maintaining conversation memory, and finally returning the AI response. Now let's see chat controller class. This chat controller acts as an entry point of AI agent. Whenever a client sends a request to our application, this controller receives it and forwards it to the chat service. Next is GitHub service class. Initially, we have added a method called get repositories. This method simply calls user slash repos and return the repositories. Before involving AI, we will expose this method through a REST endpoint and verify that GitHub communication is working correctly. We also have create repository method, which is responsible for calling GitHub's create repository API and creating a new repository on our GitHub account. Once we expose this method as an AI tool, the LLM will be able to invoke it automatically whenever a user asks something like create a repository called Spring AI Demo. So instead of just answering questions, our AI agent can now perform real GitHub operations, making it much more useful. Next is GitHub controller class. This controller exists only for testing. Before introducing AI, we want to verify that our GitHub integration works correctly. Once we see our repositories in the browser, we know the GitHub API configuration is correct. So when we open http slash localhost or 8080 slash repos, this controller calls our GitHub service, which then communicates directly with the GitHub. Don't worry, we are going to see that in few minutes. Now comes the exciting part. We will create a GitHub tool class. Instead of exposing REST endpoints, we are exposing Java methods to the AI. Notice the tool annotation. The single annotation is what transforms a normal Java method into an AI tool. Once Spring AI sees tool, it exposes the Java method to the LLM. From that point on, the model can decide when to execute it. Our first tool simply calls get repositories. That's all we need. We also have one model chat request class. It contains only one field, that is message, which stores the user prompt. Now let's see where it is used. Inside the chat controller class, add the request body annotation. tells Spring Boot to read the incoming JSON request and map it to our chat request object automatically. Now let's build the project. Open a new terminal and enter clean install. You can see build success message. So now let's run our application by Spring Boot run command. As you can see, server has started on port 8080. So let's test this in a browser first by entering URL and slash repos to verify that GitHub communication is working correctly. Yes, it is working correctly. Now let's test our GitHub AI agent in Postman. We will send list all my GitHub repositories. Notice something interesting. We never wrote if message contains repository or any switch statement. Instead, the LLM analyzed the request and decided that list repositories was the correct Java method to execute. So here Spring AI invoked the method and GitHub returned JSON, and AI converted that JSON into a human friendly response. This is tool calling. We can also create repository in GitHub. So let's ask create repository Spring GitHub demo 1. As you can see, the repository has created successfully. Okay, now I'll simply ask what repository did you just create? Notice that I never mentioned the repository name again. How did the AI know the answer? We never mentioned the repository name in the second request. That's because we have configured the chat memory in chat service class so that AI can remember conversation memory. As you can see, I asked the AI to delete the repository. However, the AI responded that it doesn't currently have the capabilities. Why did that happen? Because we haven't created a delete repository tool yet. If you would like to see how to add delete repository tool and make our GitHub AI agent even more powerful, let me know in the comments below and I'll cover it in the next video.